we are starting a new chapter, understanding users and disabilities. In the first recording, we will have lots of technical stuff, so we'll have lots of examples. After the first chapter, which was quite theoretical, so let's just jump in. We are having many disabilities, many types of disabilities. There is no single one, because there are many people differ by diagnosis, severity, assistive technology they use to daily live with their disability, environment, preference. For example, there are visual, auditory, motor, cognitive types of disabilities, and this is a practical map for design and development, but it's not like there is nothing more than this, and it can be something in between, can be less severe, more severe, because many people experience overlapping needs and situation limits. For example, as we said, you can be in an unnoised environment, or you can have one hand occupied, or can be bright sun, which can feel very similar to permanent barriers. So, as we already said in the first chapter, building flexible interface helps everyone. People who are blind or have a very low vision often rely on screen readers, on a braille or a combination of those. They need a proper reading order, meaningful names for controls, text alternatives for images, and states that are exposed in code, not only visible on the screen. Low vision users may use browser zoom, OS magnification, high contrast themes, or custom style sheets. They need reflow without horizontal scrolling at common zoom levels, text to be resizable, and strong contrast between text and background. Color blindness, or to be more precise, color vision deficiency, affects how the user distinguish hues. Red, green confusion is common, but blue, yellow exists too, and never convey meaning by color alone, pair color with text, icons, patterns, or labels. So, for example, here we can have an example where meaningful and decorative images differ in how you expose them to tech. For example, to tech assistive technologies. This is here we describe image in the alt attribute. Here this is only decorative, so empty alt means that the screen reader will skip it. Icon only, the name belongs on the button, not only on the icon. So we have the aria label on the button, and where is the image? In the middle. We'll see how it works. So here you can see the code, and here we'll have small demo. See, this is the first, second, and third example. We open screenreader in system settings, accessibility, voiceover, and you enable this on Mac. On Windows, it's slightly different.
Welcome to VoiceOver. VoiceOver speaks descriptions of items on the screen and can be used to control the computer using only your keyboard. If you
can hear that it's talking a lot. So now let's see.
Closed, leaving the awesome visual. Edit meaningful and decorative images. Example in CodeSandbox. Image.
This was the first.
Edit meaningful and decorative images. Example in CodeSandbox. Image. Close dialog. Button. Visual. Blindness. Low vision. Color blindness. Web content.
The second.
Edit meaningful and decorative images. Example. Visual. Blindness. Edit me. Close dialog. Button.
You could see the this is the close dialog, and here is
edit meaningful and decorative images example in CodeSandbox image. Edit meaningful and decorative images example in CodeSandbox image. Close dialog button group.
and here when you see here when I move
Edit
between,
meaningful and visual. Space with system settings. Voiceover off.
there is no this alt here. Here, no. Yes. Okay, so that was the first example. Screen reader. Next example. Mm, mhm. One moment, I'm missing one example with forms on my slides. This example with forms. So what we can see here, and that the form errors, for errors, we are trying to pair the call with text and programming states. So it's not only red board only, but there is also some kind of text. So we are combining text and color. Here the color is on the of the border, and here of the form we add some little gradient. Then we have color of this text, and then we have the text itself. And this is telling assistive technology that the value failed validation. And this is just where it links the input to the error text, so the screen reader can read both with both of those. Okay, so now we will see. I will copy this link, go here, and we will see. This doesn't do anything because it just hard coded to show error again.
Welcome. Email. Description. Enter an email address in the form name at example.com. Edit text email. To leaving visual. Block window. Leaving list. Enter an email address in the form. Email. Entering visual. Blindness. Low vision. Color blindness. Web content. Email. Enter an email address in the form name at example.com. Invalid data menu pop up. Edit text email. Leaving visual. Leaving group. End visual. Blindness. Low vid. Voiceover off.
So there was a invalid. Invalid form or invalid data. I don't remember when it was reading this. It was reading this when we have been here. We had focus here. It was described by this. So it was reading this text, and it was say invalid form. Yes. So that's the second example. Now there are different types of colors problems. Those protanopia, deutentropia, and tritanopia, and there are also others. They describe type of red, green, or blue, yellow color vision deficiency. Protanopia and deuteranopia affects the red-green axis, which is the first versus the second cone types in UI, and tintanopia affects the blue-yellow axis and is rarer. It's less common. On the web, the practical takeaway is the same. Critical information like errors, we have seen the previous example, requires field, chart, series, status indicators must not depend solely on a color, because some users cannot see. So we need to use labels also, shapes, positional patterns, and check contrast for text and graphics objects, not just which color looks different to me. So you can, if you protanopia versus deuteranopia versus tritanopia, and then you check just images, you can see lots of information on this if you want to read a bit more, but it's basically different type of color. But how we can simulate this in the browser? We can. So if I click right, inspect, and I go to, yeah, I already have it. I go here. If I go here, I click more tools and I click here. So I will remove it. I click here more tools and I click rendering. I can emulate vision deficiency, and I can say, for example, blurred vision or reduce contrast, or what we have hit, no red, no green, no blue. Okay, so this is in our slides. Let's see some more known examples. For example, here, YouTube. So you can see feed of my YouTube. For example, blurred vision, how it looks. Okay, reduce contrast. Okay, no red, no green, no blue. Yes, no color. So you can emulate how people with different problems they do. Achtomotopsia I didn't talk about. So there is one more you could check, read about. Auditory. So you have problem with hearing. What you can do? Auto playing, for example, can be very disruptive or difficult to even use. You need to provide user control over playback and volume for live meetings or events planned for live captions or professional some services, but this is level up, so think for captions. Spoken instruction should have a written counterpart, and remember that the sign languages are full of languages. For pre-recorded media, captions are the baseline basically. And then if you go to WCAG guidelines, it's like it will be the AAA, AAA enhancement. So let's quickly look. Video controls, so you have the controls, video, and then we have the video and we have captions. Okay, how it looks. Yeah, so this is the code, and it's better to view it here, so it's not autoplay. I can click.
Close your eyes. Why?
Let's say I cannot hear, so I have still captions, so I can still learn. I can still watch it, or I know I am. It's very noisy. I'm in a party. I can still see it, so it's even for people who don't have any problems. Very useful. So now I will turn this on, where you can hear it.
Great.
Yes, it said great.
Thing. Improve. Exactly the same. Nothing. Great.
Yes, and then there are also other controls. Okay. Dyslexia and reading difficulties. It affects the person, of course, on in terms of fluency, but decoding also of the text, like reading. On the web, support with comes from clear structure, headings, lists, and one idea per paragraph. So semantics is very important. Navigation is very important. Plain language is very important. And consistent layout is also very important to fight dyslexia as a developer or a designer. Avoid some dense, justified blocks also. Left alignments are helpful, so better to have text aligned to left than justified. And let user customize, so the user can zoom, they can reflow, and don't embed critical text in images. Like we have seen in the previous couple of slides before, you can have so-called alternative text in images and let it read. Fonts and spacing are also useful for a person. and contrast, of course. Autistic people are diverse. We try to be, for those people, we try to have pre-table workflow, so no unexpected autoplays. So when I open it here, it's waiting, it's not playing automatically. So no noisy animations, which are causing stress for these people as well. No flashing, overlapping sound, also it's not helpful, it's very difficult for people with autism. And very important, clear language. So make sure that you have controls like here for pause and stop, pause, stop, and yeah, so navigation is also important here. And we can also make it easier for those people with a couple of improvements, only couple. And people with medical problems that disrupt your body balance system, it's called, or people who have vestibular disorders, people who have motion sensitivity. We try to basically remove animations where it's possible. We try to provide a static alternatives where the animations are decorative, especially in this case, and let user disable the non-essential motion. And this also aligns with wcag criteria on animation from interaction, and we can have an example here. So if I go here, so we have media, like maybe you've been using CSS media queries to target some kind of most likely size of a screen, smaller one or a larger one. Close it. There's some class which is has opening and closing tags, and we set animation none. So this is here. So you see there is a animation coming. Here's the code. Here the animation is coming. And what will happen if I will do here? I will go accessibility, and here I will go to display, and here I have many options. I can increase contrast, for example. You can have non-blinking cursor, for example. You can invert colors. So this is also many people don't know. You can show toolbar steps, show window icons, many other things. But we want to, in this example, reduce motions. See, it's gone. Back, it's moving, and this decorative animation is not essential. So, if possible, remove it. Have this, if possible, have this prefers required motion set to reduce, and include the animation which are not essential. Okay, so that would be everything for this class. It was the first very practical class, and now we'll have another class about screen readers and how they are interpreting content, so we'll focus on screen readers in the next recording.